Assalamu alaikum students. Today in physics we are learn electric field, capacitor, electromotive force (EMF) in electricity. First we learn about electric field. An electric field is a region of space where a charged object experiences a force due to its charge. Field lines, because there are two charges that move in different directions. In a field, it has decided that field lines should show the direction that a positive charge would accelerate if placed in the field. In this diagram, the positive charge is away from the center and negative charges move towards the center. The electric field is always directed away from the positive charges and towards the negative charges. Electric field lines and direction. The strength and direction of electric field are represented by the electric lines of forces or electric field lines. They are imaginary lines drawn around the charge. The lines are drawn with arrows to signify the direction. The lines come out from positive charge and terminate into a negative charge. Therefore, the direction of the field indicates the direction towards which a positive charge moves when it is placed under the influence of another charge. Electric fields, more example, the arrow are always show the direction that a positive charge would move in the field. In this diagram, you can see the arrows moves away from the positive charges. This is our positive charge and this is our negative charge. The lines go through the negative charges of positive charge. From this side and this side, the arrows move away from the positive charges and move towards the negative charges. In the parallel plates, the negative charges and positive charges move towards the negative charges. Arrows represent the charge's direction. Electric field intensity equation. The strength of electric field in the space surrounding a source charge is known as the electric field intensity. Mathematically, an electric field is defined as the electric force experienced by a unit charge. The following equation give the electric field vector. E is equals to F upon Q, where E is electric field, F is electric force, Q is electric charge, and SI unit is volt per meter, Vm, or Newton per coulomb. And the derivation of the electric field intensity, where electric field intensity is equals to force upon charge, where E is equals to F upon Q. E, the value of F is equals to K Q1 Q0 upon D2, where the D is the distance according to Coulomb's law. These are the charges Q and Q0, where E is equals to K, Q0 and Q0 will be cancelled, and we have remaining Q upon D square. Now, E is equals to 1 upon 4 pi epsilon naught Q upon D square, where 1 upon 4 pi epsilon naught is the value of K. Types of electric field. Electric field lines are two types. First, uniform electric field. The electric field is said to be uniform if its value remains constant over a region in space. Its magnitude does not depend on the displacement, and the field lines are parallel and equal spaced. Example, a uniform electric field can be created between two charged parallel plate or capacitor. The field lines come out of the positive plate and terminate into the negative plate. Now the non-uniform electric field. The non-uniform electric field. The electric field is non-uniform if its value does not remain constant over region in space. In this case, electric field lines are not parallel. For example, the field generated by a point charge is radial and its strength depends on the distance from the charge. Now the capacitors. What's capacitors? A capacitor is an electrical device for storing charge. Generally, capacitors are made from two or more parallel plates of conducting material separated by a layer or layers of insulators. The capacitor can store energy to be given to a circuit when needed. The capacitance C is defined as the ratio of the stored charge Q to the potential difference V between the conductor. C is equals to Q upon V. The capacitance is measured in the farads, and 1 farad is equal to 1 coulombs upon volt. Parallel plate capacitor. Fixed two metallic plate A and B stands as shown in figure. You can see in the diagram. The charged metallic plate A positively in small steps. This can be done by rubbing a glass rod against the slick cloth and then touching it with plate. This process may be repeated many times to enhance the amount of charge on the plate. You can see the diagram. This is the negative charges and this is the positive plate charges. This is the A plate consists positive charges and this is the B plate consists negative charges. This increases its potential. It must be kept in mind that process cannot be continued indefinitely. After a while, the plate A cannot be charged anymore. The amount of work done in carrying positive charge to the plate is converted into the electrical potential energy. The other plate will have negative charge indeed on it, and these positive and negative charge hold each other, the system of these two plates. Now the electrical motive force, e.m.f. When a source of electrical energy such as cell is connected to an electric circuit, it produces current which passes through all the charge around the circuit is called electromotive force and is defined as the potential energy applied to each unit of charge. The unit of EMF is volt. EMF is equals to energy supplied divided by the charge. Thank you very much.